everyone, Sir Janus here. Journey with me as we discover you wake up and you cannot find your phone. What would be your reaction? Would it be the picture at the top? Or would your reaction be at the bottom? Whatever it is, definitely that will be a problem. Let's relate scientific method with this situation. You wake up one morning and you can't find your phone. Now that's a problem for most. You check your bed if it is anywhere to be found. Now that's an observation. Not finding it, you do a little research to where you probably left it and decided it might be underneath your pillow. Then that is your hypothesis. You proceeded by checking your pillow. It is an example of an experiment, only to find out it's not there. That would represent your second observation. So you do a little more research and think hard where you last used your phone and thought you must have left it on the pocket of your pants. Then that is more research and your second hypothesis. So you quickly get out of bed and check the pockets of your pants, and to your delight, you found it. So that is now your conclusion. So you quickly texted your friends why you haven't replied to all their messages. Then that is the last and the final part of the scientific method, which is sharing of results. What really is the scientific method? Is it for everyone to use? To put it simply, when we talk about the scientific method, it is a way to solve problems. So do you have any problems to solve? Then, you can utilize the scientific method. When we talk about the scientific method, it is a way in which scientists gather information and answer questions. Remember that the goal of science is to investigate and understand the natural world, explain events, and use those explanations to make useful predictions. Generally, 7 steps is followed for the scientific method. If you are going to look it up at the internet, you might be amazed as to how many examples there are on how to make a scientific method. But actually, these are the diagram on the right clearly exemplifies what is a scientific method. So this is a good flow chart of the scientific method, and there are many versions of the steps of the scientific methods, but essentially they are all the same. Now, we are going to explore the So the observation is based only on smelling. So the probable inference for this one is that the neighbors are having a barbecue. So as you can see, although you could not see what they are doing just by the smell alone, you can already infer based on your prior experience. Okay, so before we proceed with the next stage, let us have a quick activity, so called the game show corner. So we would be focusing on the type of data, the quali and the quanti, together with making inferences. So are you ready? By the way, each question, you will only be given 30 seconds to answer. So let's start. So for the first activity, in making observations, so you are going to identify whether the statements here suggest a qualitative data or the statement suggests a quantitative data. So here are the statements. The candy was sour. Number 2, the bag was 5 centimeter long. Number 3, the flour is red. The mass of beaker was 122 grams. My fingernail is 2 centimeter long. The slug was slimy. That laptop is white. She is 150 centimeter tall. His hair is black. You have 3 sisters. So, are you ready to answer? On to the next one. So, this activity is about making inferences, but by this time, you will only be given 30 seconds. Okay, so First up, you will be given an observation, and what you will do is you are going to identify what are the possible inferences. So the observation here is the plants on your yard is wet. What do you think are the possible inferences for this one? Okay, timer starts now for 30 seconds. Think of a reason or the probable cause why you think that the plants on your yard is wet. So 10 seconds left. Five seconds. And time's up. So here are the probable inferences. So it rained, your mother watered the plants, there is dew on the plants from the morning, and it can also be that a dog urinated on the plants. So those are the probable inferences. Okay, let's proceed with the next one for making inferences. The given observation is that the school fire alarm is going off. What are the possible inferences? So just like the first one, you will only be given 30 seconds for this one. Okay, so 15 seconds more. Okay, 5 seconds left. Okay, so the possible inferences for the school fire alarm going off is that the school is on fire. That's the most probable one. Or the school is having a fire drill. Or a student pulled the fire alarm. Or maybe it went off because of a faulty wiring. For the next one, making inferences, the observation given is a student is sitting in the guidance or the principal's office. Now, I know many of you here could relate for this one or have a lot of ideas or the possible inferences. Okay, so just like the other two, so you will only be given again 30 seconds for this one. So what do you think is the reason why a student is sitting in the guidance or the principal's office? Okay, so you still have 20 seconds left. So think, what are the probable reasons or the possible inferences for the given observation? Okay, so 5, 4, 3, 2, 1, and time's up. So here are the most or the probable inferences. So maybe the student is called for misbehavior. The student is seeking help or guidance, either from the principal or the guidance counselor. The student is conducting an interview, or maybe the student is just asked to get something from the office. Now let's proceed with step number 3 of the scientific method. So after identifying the problem, getting observations or research about the problem, now it's time to form a hypothesis. So what is a hypothesis? So when we talk about this one, it is defined as a proposed solution or educated guess to the problem. So they must be proposed in such a way that they can be tested or testable. There can be multiple hypotheses or many solutions to a scientific problem, and usually a hypothesis is written as if and then statements. From the diagram, you could clearly see as to how scientists answer questions. So after identifying the problem, they will come up with observation or research about the problem, coupled with the inference. That's the only time that they are going to create their hypothesis. So we have here an example, an observation. This cat is big, the other one is not. the probable inference for this one is that one cat eats more food. So its possible hypothesis is that if the cat or if the big cat eats less, it will not be as big. So that's the connection between the three. We will be proceeding now with step number 4 of the scientific method, and it is known as testing the hypothesis. Now, when testing the hypothesis, there are two main parts. You have, of course, the materials and the procedure. Of course, the material refers to the list of all the things you need or the supplies, whereas procedure refers to the step-by-step instructions, and also you are going to identify the variables used in the experiment. So what are these variables? When testing the hypothesis, there are three variables that you must consider. First one is the independent variable, second one is the dependent variable, and the third one is the controlled variable. Now, it is quite easy to differentiate the three. When you talk about the independent variable, it is what you change on purpose in an experiment. Okay, so you can ask yourself this: what did I change? On the other hand, dependent variable refers to what you measure in an experiment. This refers to what do I observe. And for the last one, the controlled variable is the condition that remains the same in an experiment. To differentiate between the types of variables, here is a clear example on an experiment to see what would be the effect of varied liquids on the growth or the health of a plant. Now, for this experiment, as you could clearly see, the independent variable here, or the variable that is being changed, is now the liquid used to water each plant. On the other hand, the dependent variable here, which depends on the type of liquid, or the independent variable, would be now the height of or the health of the plant. On the other hand, for this experiment, the controlled variable here is either the type of plant, pot size, the amount of liquid, and soil type. So this variable is not changed. After testing the hypothesis, it is now time to organize and analyze data. By the way, when we talk about data, these are recorded observations and measurements. The data collected during the experiment is usually shown in a table or chart. So why do we need to use charts? Of course, this makes information easier to see. Now, in creating a chart, you have these four vital informations that should be present. Of course, there should be the title, wherein it shows the effect of the independent variable across the dependent variable. The y-axis now represents the dependent variable, and the x-axis represents now the independent variable. And of course, another important thing here that should be considered are the key for data series, or the legend. So what are the graphs that you could use in presenting the data? Now, there are various types of graphs, but the most common used are, of course, the line graphs. This is used when you want to compare a number to a number. A bar graph if you want to compare a number to a word. And rarely used, but still you can use this one if you want to display percentages or parts of a whole. validity of your results? How might this experiment be improved or modified? The scientific method by taking up this quiz challenge. So are you ready? By the way, you can pause the video anytime you like to give you time in answering the questions. So enjoy.